What I want to do next is talk about the issue of floors. So let's go and take a look at them. Because floors have all sorts of interesting little nuances to them too. For the most part, we looked at floors the other day, and we did pretty good. The big idea with floors is you got to sketch the boundary, make sure it's a continuous loop, and close it. All the troubles people have with floors is it's all loop. You know, either you got a loop that closed or you don't have a loop that closed. And if it didn't quite close, sometimes you have to do some trimming and really figure out why it's overlapping or why it's quite disconnected. It's all about just getting that loop to look good. So for cutting the floor openings, there's this whole idea of if you create a floor, you can cut an opening in it by adding some sort of interior loop or by modifying the boundary. But let's start there. Let's just go ahead and start creating some floors and try putting some openings in them and kind of see how they're interacting. So I'm going to go back over here. And in my very simple little model here, I will go through and I will change that back to, actually, that's so good looking. I'm just not going to, I'm going to keep that around. I'm proud of myself. Let's go ahead. I'll choose a different wall type. Let me go for, I don't have those wood ones that you have. I'll just do the brick on the metal stud and create another little building right next door. Interestingly, it looks like it's inside out. Let me show you this. See if I can get this to work. The brick's on the inside. That's bothering me. As you go through and work and do selections, okay, remember there's control click to add another one, control click to add another one. Let me show you another one that's a good sort of technique for you to know about. I could select that and then control click to get this one and control click to get that one. Okay, and that would work. But if you have a nice continuous loop of things, hover over one of them, tab, and you get them all. Ooh. Then I can right-click on that and say change the wall's orientation. That'll flip them all inside out. Well, I take that. Oh, that's interesting. It did. Once again, making a liar out of me. It should do that, but if it's not going to, I'm not going to fight with it. It's only changed that one. I would expect it to change them all. So I'm going to flip these ones too. Ignore my tips and techniques which don't work. The tab works. That works. It's just that we can't actually change them all at the same time. So here we are. We got this wall. Again, these walls are 20 feet tall because we didn't do anything special to them. We just left them being 20 feet tall, unconnected. Okay, leave it at that. Okay, let's start putting some floors in here. We're going to put a floor underneath this thing. And, yes? What you can do is, evidently one at a time, I'll correct now, and you're not going to notice the fact that I made the mistake earlier. You can choose the wall, and you can right-click on it and say change the orientation in a 3D view. Or probably the easier way is just in a floor plan view, select the wall there and flip the arrow. So again, I'll go back over to the floor plan view, and when I select the wall, these little arrows appear and I can flip the orientation that way. Let me zoom on in a little. Here's the deal. We're looking at a view. This is actually a wall that has a lot of layers to it. It has a core to it. You just don't see the layers right now because at a coarse level where this view is set to by default, okay, it just sort of simplifies things and only just shows us the inner and outer surfaces. It doesn't show us all the detail. What I'm going to do is switch my view over, so instead of being a coarse representation, show me more of the fine detail. And then it'll go through and show me the specific layers of the wall so I can start to see which is the core. The core of this wall is actually, it's these inner parts right there. It's the metal studs. The brick is really just a finish layer on the outside of the core. Okay, so I got the wall, some walls over there. What I'm going to do is start by creating a floor. That one's still flipped. Okay, zoom out. That's looking better. All healed up nicely. Okay, What I want to do now is as follows. I want to go through and put a floor under this thing. And to put the floor under it, we're going to choose the floor tool. Floor tool we can choose by footprint. Actually, floor just works by... There's variations on the theme, but we're just going to choose floor. We'll learn about structural floors later. It's a variation that has structural properties. I'll pick some walls. There's the choice, should I extend into the core or not? Let's talk about what that is. When you pick the walls, the idea is when I click on this wall, that's actually it went to the other side of the core. That's into the inner face of the core. Let me flip it. That's the outer face of the core. It just has to do with where I clicked. It's choosing the face of the metal studs. That's the core of the wall. And that's actually where I want to choose the floor too. Let me go through and I will click again and I'll say extend this one to the core. Okay, and I'll just do that for the other walls too. I'll do that one to the core and I'll do that one to the core. But let's just close the loop. We'll sort of create sort of a simple surface. I'll show you when we do the second floor what the difference is between the core versus doing it to the surface, because it'll make more sense there when you see the floor kind of bleeding out. If you want to put a hole in your floor, feel free to do it. Just grab something you like, put it in there. The only thing is your inner loop can't cross your outer loop. You have to keep your loops separate. You can put multiple holes in there. If you're really feeling sick and twisted, you can put more solid mass inside. And that'll create a solid inside of a void inside of a solid. Okay. But we can create our floor. And then if we take a look at that in 3D, you'll see, there we are. But that's all just one floor sketch. Now, by default, it puts the floor at the level and then below the level. Okay, so the top of the floor is at level 1. It's actually extending below down into the ground. Okay, and that's okay for where we're going right now. Let me go ahead and show it to you a little more clearly. If I go to one of the elevation views, for example, you can see here are the walls. And the floor is actually going down from level 1. So it's extending down into the ground. Now, someone asked last time about this, and it turns out that's not really a true condition. Yeah. What we will do is, we like the floor to go down, but we tend not to like these sort of funny gaps where the wall is sitting right on top of the floor. We tend to have actually the finished layers of the walls wrap around the floor a little bit to kind of give them a little protection, not create a little gap where water can get into the building. And how you do that on your first floor walls is you can choose the wall and you can look at its type properties, or instance properties, excuse me, and see that it has a base offset where you want it to just drop down a little bit. And what that's going to do is it'll drop the finish layer around the outside of the floor. So this is actually sort of a much more common condition. We really sort of build things in this way where the finish layer tends to wrap around a little bit. That's sick. Actually, it's a funny little thing that's going on right there. Generally, that gray, that's the floor. I'll do it back in the elevation. It'll be easier. My 3D view is too big. So you can sort of see here, for the side wall, it's still sitting on top of the floor. This one's wrapped down. And if I would go ahead and wrap this one down in the same way, and we'll say, again, the type properties or instance properties, and bring it on down, then it'll clean up nicely at the corner because they're both down at that same level. It has a hard time mitering two things when they're at different levels. Yes? And that drops the top down as well? It does? Well, let's talk about that. Good question. Very good question. It does, in that since these walls are defined as being 20 foot unconnected, okay, it would bring it down because it's going to honor the 20 feet. That's the strongest constraint it has to deal with. However, if you had that instead locked to like level 2 or roof or something, then that would stay constant and you're just pulling the base of the wall down. That's sort of another good reason not to leave things unconnected, because that unconnected, as soon as you move the base, the top will move with it. And you often don't want that to happen.
It looks like they did away with the base offset in 2012. I'm not seeing it on there.
It's an instance property of the wall. Let's check it out. It's because you're in type properties. Go ahead and kind of OK to that, and it's an instance property. Okay. So first floor walls, those tend to be fairly straightforward in terms of what's going on. What I want to do is actually draw a second floor wall so that we can kind of look at how walls and floors interact a little bit in terms of what's going on here. So let me go back to the slides for just a second. So this part, you define a boundary, you sketch the boundary, any interior loops. That's pretty straightforward in terms of what you need to know there. Okay, instance properties of the floor. The level it's associated with, the height offset, and any sort of room bounding. Let's talk about that for the floor. You can choose that floor. And we can place it right at level 1, or we can give it a little offset if we'd like to be above or below a little bit. Sometimes, for example, I'll use this if I'm doing a deck or some sort of exterior landing outside of a door. I'll have the floor hosted at level 1, but I'll just give it an offset of like -2 or 3 inches just so you step down outside the door. You need to step down a little bit outside there. Okay, so you can give an offset to it. That'll just lower it relative to the floor. There's a notion over here of whether something is room bounding. We'll talk about that when we're defining rooms, but generally rooms are defined by the walls and a floor surface and a ceiling surface above them, and the volume of the room will be defined by those things. But sometimes we say that we don't want it to be room bounding, and it'll let the volume penetrate through the floor. Subtle distinction, don't worry about that just yet. You'll also see things like the perimeter, the area, the cubic footage of the concrete or whatever it's made of are being reported here too. That's numeric data that actually is available to us and we could use to start doing some estimating or doing some sort of tabulating of what's going on. Okay, so we got these type or instance properties to work with. We also have type properties, and let's take a look at them. You can choose different types of floors. For example, like a wood finish floor or a carpet finish floor. And very much like the properties of the walls are defined in the type, you can assign the layers of the floor right here. So for example, I'll say type properties. And it has a structure that's going to look very much like the walls. And within there, you'll see that we have wood floor as a finish layer. Then we have a couple of different structural layers, structural wood and wood sheathing. Okay, there's a thickness. This is perfectly parallel to what we've been doing for walls and roofs and other sorts of assemblies. It's just you define the different layers that you want. So if you don't want a wood floor, or you want a wood floor that's thicker, or you want a cork floor, or if you want just some other surface material, define, duplicate, and kind of change the materials to be what you want to have on those surfaces as opposed to what's already defined in the library. Okay, so that's all that's going on there in terms of the different floor types. Even in terms of the thickness of the floor, if your floor is going to be made out of 2x12s as opposed to 2x10s, that might be 11 1/4. But actually, I should change the name if I'm going to do that. Always be very careful. When you go through and change types, it's probably better to duplicate the type and change the duplicate as opposed to changing the root one, because if you change those dimensions, and even though you promise yourself you'll be good and remember that, someone tomorrow is going to try and do that, and they'll be choosing 10 inches and wondering why your floor is 12 inches. So watch out for that. Okay, so those are the type properties. We won't belabor that because that's so similar to walls. I think you'll get the hang of that really quickly. In terms of these types, let's talk about floor types and how you copy them around a little bit. If you've defined a type that you really like, a wall type, a floor type, a roof type, something like that, there's this whole notion of how you copy things between projects. Within a project, we just duplicate an existing type and change it. But let's say you put together a floor that has some special materials, it's a stone floor, and you want to use it on a different project. Okay. Things like components, doors and windows and pieces of furniture which are loaded out of a library, you can just save as, and then we can load them into the other project. So they're just changed as files. You save a file, you load the file into the other project. Okay, and that works out really, really well because we can all use the CE1110 library, put it out on a file server, we could all share those parts. It's really, really easy when things are these component families. Okay, for these things, these are called system families. It's a little bit harder because you can't just save your floor type out there. It's really more a definition that's going to define geometry. It's not really a piece of geometry. Okay, so we have to do something a little bit different. And it's this thing called transferring project standards, which will be useful to you. Let's just talk about how that works. So if, for example, I'm over here, I got this wood finish floor. Let me duplicate this floor. I'll say I have a nice type. I'm going to duplicate this. I'm going to make it the cork finish floor. And then for the structure, I'll change the material from being wood floor. I'll create some new material that I'll call cork. I can give it a color. I can give it a pattern. Whatever it is. Oh, it's going to be sort of like a kind of a pale brown color, something like that. Give it some sort of pattern. It doesn't want to look like this. Maybe it wants to look more like, oh, what does cork look like? I don't really have a good pattern for cork. I'll give it more of a tile appearance. So I'll say, okay, apply it to this floor. I now have my new cork floor hanging around in there. So it's kind of good. I've just defined a floor type. I would love to share it with you. I'd love to share it with another project. I want to keep on using it. So here's what I got to do. If you have a different project open, let me open a new blank project. Okay, defined on a different template. This one's hanging around. It's going to open on up out of the default template. And that floor type, that custom floor type, is not going to be there because it's defined only within that one project. So over here, I have the floor. I look at the floor properties, and I don't have that guy. It's not hanging around. What I need to do is as follows. If I want to transfer, again, walls, floors, roofs, or ceilings, these are all called system families. What I do is I go to the Manage tab, and there's this thing called Transfer Project Standards. And what does it let you do? It lets you copy families from one project into another. So I'm copying out of project 2 into project 3, and I can say, what I really want to get are all the floor types. There we go. You can actually copy a whole bunch of different things. This is sort of how you copy things over after you, if you've created a project and you didn't have it work off the same template. It's how you pull things across. And when I do that and bring them across, it says some of these things already exist. I'll just overwrite them. And by transferring the project standards, all that it's really doing is making available to us in this project now the things that I copied out of the other one. So that's just to sort of know about. It's one of those like things every once in a while. You put all the work into developing a nice library of materials and things like that. Actually, you can copy materials. You can copy all these things across. So the idea is you want to be able to share these things. So now my cork finish is in there too. So get used to the idea. Some things we save out, component families we save and then reload. But these system families, you can even tell it's a system family. It says so there. Okay, you use transfer project standards to get them across. Okay. That probably won't affect you anytime in assignment 1. It'll hit you later on in the quarter when you really want to I defined the perfect thing back in assignment 1 and I'd like to use it again in assignment 3. So you go sort of harvesting out the parts you like from assignment 1 and pull them across. Yes? How we get to that? Yeah, no worries. What happens is you have to have 2 projects open, one that has what you like. So, I have 2 projects open right now. I have the new one, just a big blank project, and I also have a project open which is the older one, which has the thing already defined in it. So I can switch over to project 2. So this has the thing defined in it. This other one's just a separate project. So I'll switch windows. I'll go to project 3. I should give them better names. That would somehow be helpful to you. Okay, and we're like looking at just sort of an empty project. So what I do is I go to Manage, and you'll find Transfer Project Standards, and that'll let you choose from the other projects that are open right now. So your dimension styles, your duct sizes, there's the materials, if you've defined a lot of custom materials, all that stuff can kind of come over that way. So just know about that. It's good to have in your bag of tricks. Okay, so types and copying types. I think you'll get the hang of that. We want to finish up with at the break. I'll leave the slab edges for right now and talk about the whole notion of walls and floors and how they intersect with each other. And we haven't noticed it very much yet, because as we put floors under the first floor walls, the floors tend to be underneath it. So they're not really intersecting. But if we do a second floor, it'll actually intersect, and we'll have to think about this. So let's kind of show you how that works. And this diagram is actually a good illustration of really what we're going to be getting to. When we have floors and walls intersecting with each other, there's this notion of really what the relationship should be. Okay? This floor and this wall are defined in such a way that the edge of the floor is to the core of the wall. So the floor joists are coming up to the edge of the studs, but they're not actually penetrating out. Okay? There's this whole thing about where you put your floor lines, to the exterior face or the core face. And if you stay to the core face, the structure will be held back and the material will wrap. So that's one of the things we're going to be playing with, is just this whole notion of where you put the line. Okay? Another thing we're going to play around with is this whole notion of really some questions that come up. Do you want to attach walls, and do you want to cut out overlapping volumes? And the answers are generally yes, but let's show you what the effect is of answering both different ways. But to do that, come on back to the floor plan, and let's just sort of put another floor within there, and you can see how this all fits together. So I'm hanging around over here. I got these walls. They're like 20 feet tall, I think, right now, if I remember properly. Instance properties. Yep, 20 feet unconnected. Super. What I'm going to do is I'm going to put a new floor at level 2, and because I'm putting it at level 2, it's going to intersect with those walls because they're sticking up so high. So how to do that? I'll go to level 2. I will say that I want to create a new floor. Within the floor choice, I'll choose the floor. And now I'm going to have some choices. Once again, I'm going to pick the walls, and I'm going to extend the walls into the core generally. Let me go ahead and say this one's going to extend to the core, wrong side of the core. That's going to extend to the core, and that's going to extend to the core. Okay, and again, what that's doing is it's putting the floor up to the face of the studs. Okay, but for the last wall, let me do something a little bit different. Let me choose to put the wall here, but not extend to the face of the core. Okay, so in this case, I'm actually extending to the exterior face. So you get what I'm doing? Okay, let's go ahead and take a look at what the impact of that is. When I finish it, okay, it's going to ask me some questions. For now, just say no to that. We'll say yes in just a minute, but let's just say no. Let's take a look in 3D. Yes?
Which walls did you not extend to?
For me, it was, I didn't extend it on the one. The one on the right-hand side, I didn't extend it to. So if I go to level 2 again, and let's see if I can get that floor. There it is. I'll edit its boundary.
How do you create an extra floor?
Say again?
How do you create an extra floor?
What you need to do is just go to a different level, like level 2, and then just choose the floor tool. Oh, sorry?
Extra level.
Oh, an extra level. You want a new level. No worries. Let's show you that too. Okay, let's say finish this floor. We're off on a brief aside. It'll be a very brief aside. If you want to create a new level, what you do is you go to one of the elevation views, and you'll see, let me zoom on out. There we go. There's level 1 and level 2. If I want to create a new level, what I do is I come through and I can choose under the Home tab, there's the Level tool. Every time you drag out and draw a level like this, it'll create a new floor level. That'll be level 3. And notice as I add level 3, it'll show up here in the list. I can go through and create level 4. Now, just so you know, because I like to share tricks with you, this whole notion of adding all these floors individually can get sort of tiresome after a while. So what you can do is use offsetting. If you're familiar with offsetting and using offsetting from some CAD programs, we can pick things and choose an offset. For example, if I want the floor-to-floor height to be 10 feet, and choose that, and it'll create the new floor levels with me. And that's probably the quickest way to go through and create a lot of different floors. If you want to create like a tower of some type, you could also array them. But offsetting is just sort of a very good way to do that. So create some new floor levels if you don't have them. But let me go on back, and we'll take a look at that floor that got added and see what happened. Okay, here's the issue. Here we are hanging out. This wall was to the core. This one's not to the core. This one's actually, the floor sketch was extended to the exterior surface. So what's happening, I think you can sort of see here, we have a little bit of what I'll call ugliness happening. It's bleeding through. The floor is kind of bleeding through the exterior surface of the wall. Okay? And we don't generally want that, because even as in a construction detail, if we had that exterior floor to the wall, we'd have a little gap right here where water could get in, and we'd have just sort of a weatherproofing problem. So rather than going through and extending things to the exterior face, it's very rare that you want to extend to the exterior face. To the core is almost always a better choice. Okay, so to core is generally good. If you have a bleeding problem like this, and we'll all get this on one of our first models, just choose the floor. We can edit the boundary. And then for the wall that's sort of bleeding out, if you can select the line, just change it so it instead extends to the core. It'll push it back the few inches that is necessary. And again, I'll say no for now. Okay, and it'll clean up the bleeding problem. Okay, so just watch out for that. That's why we say to the inner or the core or the outer. You don't want them kind of sticking all the way out. Okay, the last little thing we'll show you before the break is this notion of really this question of the overlapping, and do we want them to overlap or not? And to illustrate that, let me go ahead and zoom out here, and we'll just draw a section. That'll make it probably easiest to see this. Nope, I can't place it in the 3D view. I have to place it in a floor plan view. Let me do this. I will draw a section through the building right here. We'll take a look at that. Okay. And here we are. Now again, this is a coarse view. If I want to sort of see all the layering a little more finely, I could turn on fine, maybe even turn on the colors. And let's show you what's going on here. So here we are. We have our floor. It's actually extending to the outer face of the core. That part's looking pretty good. But right here we have a funny problem, because what's happening is we've got these two different things going on. We have, the joists are sticking out, the walls coming up, and they're just overlapping. They're taking up the same space. So it's not physically right now. Our model has this funny overlap that isn't quite appropriate. So the question is, do we want to cut out the overlapping volume or not? And generally the answer is yes, you do want to cut out the overlapping volume. If you do, what'll happen is it'll clean up that intersection, give us something that looks much closer to a construction detail, and then like even in terms of the quantity takeoff, it'll be accurate numbers as opposed to having that volume counted twice. So in general, the answer is yes, you want to do that. So how you would do that, let's just go ahead and I'll choose this and I'll say edit the boundary. I will go back to the floor plan view and make the change. It turns out whenever you open a floor and edit its sketch and then you reclose the floor, or when you finish the floor and you've made any change to it, I'll just cut a hole in it. That should be enough to make it work. Say finish. We'll keep on getting this. It wants to do this, so it keeps on asking you every time, are you sure you don't really want to do this? It really was a smart idea. So if you say yes, what will happen is when I go back to the section view, okay, see it's a little bit cleaner now. And in terms of understanding what is clean about it, let me even turn on a different view that has thin lines so you can really see what's going on. the structural layers coming out to the structural layer here. You know, these layers are kind of poking out further. The finished layers are going beyond it. I don't actually have a finish on my floor, so it's not actually showing what happens in here. But even for floors, there's this notion of core layers versus non-core layers. The core layers are the ones that overlap and intersect, where the non-core layers don't. So the effect is, as you sort of see in this diagram, if you look really closely, the joists are sticking into the wall. They're bearing on the studs. Even the sheathing, because it's a core layer, is extending underneath the walls, but the finished floor isn't extending under the walls. So it's being smart. It's holding itself back, okay, which is actually the way it would actually be built. So tries to be very smart, but all you need to remember is if you stick to cores and you let the overlaps happen, in general, 9 times out of 10, you're going to get a good match. Okay, make sense?